Good morning, students. Today we are going to read carboxylic acid in the chapter of organic chemistry. This is somewhat very tricky topic, so concentrate yourself. Carboxylic acid. The general formula of the carboxylic acid is CnH2n plus 1 COOH, where N is equal to 0, 1, 2, 3 up to so on. Carboxylic acids are a family of the organic compounds containing carbon, hydrogen, and oxygen. This is clear from the formula. Carbon, hydrogen, and oxygen is there. Their functional group is COOH. Acids are named by replacing the E in the name of the corresponding alkane with oic acid. For example, methane converted to methanoic acid. So replace E with oic acid. From methane, methanoic acid. From ethane, ethanoic acid, and up to so on. The table below shows first four members of the acid family. First is methanoic acid. Formula is HCOOH. So this is the functional group COOH. So this is the functional group. Ethanoic acid. Formula is CH3COOH. So COOH, this is the functional group. And this is C single bond will be there. Next is propanoic acid. Formula is C2H5COOH. Last H will be replaced by COOH functional group. Up to here, this will remain same. Single bond will be there. And this is the COOH functional group. Next is butanoic acid. Last H will be replaced by COOH. Up to here, single bonds will be there. And this is the last functional group which will be attached. Exemptive for you students is alcohols and carboxylic acids are not hydrocarbons as they contain oxygen atoms in their compounds. Alkanes and alkenes are hydrocarbons as they are compounds that contain only carbon and hydrogen as the constituent elements. So hydrocarbons contain only carbon and hydrogen. That's why alcohol and carboxylic acids are not hydrocarbons because they contain oxygen also. Butanoic acid has two isomers. And here are the two isomers of the butanoic acid. Formation of the ethanoic acid. Ethanoic acid is formed by oxidation of the ethanol. Using atmospheric oxygen, when ethanol is reacted with atmospheric oxygen, ethanoic acid and water is formed. Using acidified potassium dichromate, so this is atomic oxygen. So this ethanol will be converted into ethanoic acid and water will be produced. The orange potassium dichromate solution changes to green. Initial color was orange. And here is the process. Anti-bump granules, ethanol plus orange potassium dichromate solution is here. Water out, this is water condenser. and from here water is in, and here ethanoic acid will be dropped in this flask. Exam tip for you students is the carboxylic acid smells like vinegar. Vinegar is in fact made up of large amounts of ethanoic acid. Carboxylic acids are weak acid but do show the typical reactions of the acids. Here are the reactions of the carboxylic acid. Two important kinds of the reactions of the carboxylic acids are number 1, acid reactions, number 2, esterification. Now we will read these two kinds of the reactions one by one in detail. First is acid reactions. When dissolved in water, carboxylic acids can dissociate to form hydrogen ion, H+. Only the hydrogen atoms in the COOH group can dissociate to produce hydrogen ion. So this H will be dissociate to form hydrogen ion. So COO negative charge plus H+. Carboxylic acids are weak acids and they dissociate only partially in water. Here is the general formula. Last H will be dissociate to form H+ ion. Here is the formula. Last H will be dissociate to form hydrogen ion. Ethanoic acid is a monobasic acid and it has only one carboxyl group in the acid molecule. Hence, dissociate to form only one H+ ion per acid molecule. So, per acid molecule, only one H+ ion will be produced. Carboxylic acid reacts slowly with metals. Also react with reactive carbonates and bases, as in inorganic acids. Carboxylic acids behave just like any ordinary acid. Carboxylic acids are weak monobasic acids. Examples are here. Reaction with reactive metals. When carboxylic acid reacts with metal, it forms salt and hydrogen. For example, ethanoic acid when reacts with magnesium forms magnesium ethanoate and hydrogen. And here is the equation. 2CH3COOH plus Mg forms MgCH3COOH twice plus H2. Reaction with bases. When carboxylic acid reacts with base, it forms salt and water. Here is the descriptive equation. Ethanoic acid is reacting with sodium hydroxide, forms sodium ethanoate and water. And here is the equation. CH3COOH plus NaOH forms CH3COONa and water. This is sodium ethanoate's formula. Next reaction is with carbonates and hydrogen carbonates. Descriptive equation is carboxylic acid reacting with carbonate forms salt, water and carbon dioxide. And here are two reactions. For example, CH3COOH is reacting with calcium carbonate forming CaCH3COO twice plus H2O plus CO2. Likewise, sodium carbonate will react with it. Next reaction is esterification. When ethanoic acid and ethanol are heated together in the presence of the concentrated sulfuric acid, a sweet smelling liquid is formed that is called ester. The sweet smelling liquid is called ester. Here is the equation. Ethanoic acid reacting with ethanol forms ethyl ethanoate and water. Here is the equation and here is the structural equation. But this reaction is reversible. This means that the ester can be changed back into an alcohol and an organic carboxylic acid. To do this, we need to boil the ester with sodium hydroxide. So this is the process by which we can change ester back into ethanoic acid, carboxylic acid and alcohol. This is in fact a reaction with water and is called hydrolysis. Here are some uses of the esters. Esters are used in soap, in food additives, in perfumes, in flavoring, in adhesives. These are some uses of the esters. Two types of the esters are found naturally. First is short chain length that is found in ripe fruits. Properties of short chain length esters are liquid with fruity smells. And these are used in flavoring, perfumes and solvents. Second type of the ester is long chain length that is found in vegetable oils and animal fats. Long chain length esters properties are oily liquids or fatty solids. Long chain length esters are used for foods and soap making. For example, aspirin is a carboxylic acid used to relieve pain and reduce risk of the heart attacks. Very important point. Other carboxylic acid includes citric acid found in oranges, lemons and limes. These citrus fruits are good sources of the vitamin C. This is another carboxylic acid called ascorbic acid. And now, here is a question. What is the structure of the ethyl ethanoate? The answer is, this is the B answer. The ethyl group from the ethanol attaches itself to the ethanoate group during esterification. Exam tip for you is, the concentrated sulfuric acid used in esterification functions as a catalyst. This is very important question as far as MCQ's paper is concerned. Another question is here. The structure formula of the butanic acid is shown. Which statement about the butanic acid is correct? C is the answer. Its empirical formula is the same as its molecular formula, because there are 1, 2, 3, 4 hydrogen atoms, 1, 2, 3, 4 oxygen atoms, and 1, 2, 3, 4 carbon atoms. So look now, its empirical formula is CHO and its molecular formula is C4H4O4. So 4 will be taken as common. So empirical formula is same as of molecular formula. Butanoic acid can dechlorize bromine water as the CC double bond is present. And other question is here. Vinegar is a solution of ethanoic acid made by the reaction of the ethanol with water. Which gas in air takes part in this reaction? Answer is oxygen gas. Oxygen is the gas involved in the oxidation process of ethanol to ethanoic acid. Exam tip is, in the absence of the oxygen, fermentation would take place instead if yeast and the correct conditions were provided. And other question is here, which of the following react with sodium carbonate to produce carbon dioxide? Answer is B. Carboxylic acid react with carbonates to give carbon dioxide. Carboxylic acids have the ability to produce hydrogen ion in aqueous solutions. Hence, they can react with a carbonate to produce a salt, water, and carbon dioxide gas. Now, we are going to read some uses of the ethanoic acid. Ethanoic acid is used with other chemicals in the manufacture of the drugs, dyes, paints, insecticides, and plastics. It is also used to make useful organic compounds called esters. And here is a figure. Organic acids are used in paints, flavorings, ethanoic acid, preservatives, dyes, drugs, insecticides, plastics, etc. There are a lot of the uses. And other question is here, what is the functional group in the organic acid? So remember, COOH is the functional group of the organic acids. And other short question is here, which organic acid does vinegar contain? The answer is ethanoic acid is responsible for vinegar contain. Next question is, name the organic acid found in lemons. The answer is citric acid is found in lemons. Next question is, how is ethanol converted into ethanoic acid? The answer is oxidation in the air is responsible for ethanol to convert into ethanoic acid. Next question is, what is formed if an alcohol reacts with an organic acid? The answer is ester is formed when alcohol reacts with organic acid. And other question is here, which class of the organic compound has a sweet smell? The answer is ester is a class of the organic compounds that has a sweet smell. So students, this was the lecture for today. Very important lecture this was. Read it again very carefully and make your notes. Thank you so much.